Okay, solving systems algebraically day 2. All right, we're going to look and see, this is day 2 of elimination. What is the solution to a system of equations? The point of intersection. So you're looking to see where the two lines, because we're doing linear systems, intersect. Okay, so two methods used to solve systems of equations algebraically. Substitution, we did that last week, and now we're practicing elimination. We did that yesterday. Okay, how do you choose which one to use? Well, look at the equations and see if both equations have x and y on the same side. If that's the case, you want to use elimination. So if the two equations are set up in standard form, remember standard form is ax plus by equals c. That's standard form. Okay, so if the two equations are both set up in standard form, you want to use elimination. If one of the equations have x or y by itself on one side, you want to use substitution. Now there's also graphing. If you ever have two equations that have a y equals, they're solved for y, then you would want to use graphing. Now any of these equations you can switch around to where you have a variable by itself, and you can use substitution, or you can manipulate it to where both x and y are on the same side and use elimination. All right, so if I take a look at this one right here, well, x and y, and they're both on the same side and they're lined up. So we're going to use elimination. All right, if I want to eliminate the variables x, I'm going to see what do I need to multiply 3 by to get a 9, and that would be a positive 3. Now, if I want to add them and have them eliminated, I would want to multiply it by the opposite. Okay, so I can get a negative 9. So I'm going to multiply this entire equation by a negative 3. So I'm going to do negative 3 times 3x, and that's going to be a negative 9x. Negative 3 times a positive 4 is a negative 12y. Put your equal sign down. Negative 3 all the way across here to negative 2. Negative 3 times negative 2 is going to be a positive 6. Okay, then I'm just going to take this equation and write it right over it. 9x plus 12y equals 3. Okay, so I'm going to add those two equations. 9 and negative 9 go away. That's perfect. Okay, 12y minus 12y, those go away too. I don't have anything over here on the left-hand side, so I've got to write a 0 down. And then 3 plus 6 is 9. Okay, no variables. Or you might say you lost your variables. Or you eliminated your variables. Both of them at the same time. Okay, look at the statement. The mathematical statement is 0 equals 9. Is that a true statement or a false statement? Well, 0 doesn't equal 9, so it's false. So my answer is no solutions. If I solve these for y equals, I would find out that they're parallel lines. Okay, all right, let's go over to number 2. Number 2 looks like it's set up for substitution. Right, the reason I say that is because the x is all by itself on the left-hand side. All right, now if I wanted to, I could manipulate this negative 2y, move it over to the right side, and I could solve it by elimination. So I'm going to go ahead and do substitution. I'm going to take this negative 1 minus 2y. I'm going to substitute it right in there for x. So I've got 10 times negative 1 minus 2y plus 20y equals negative 10. All right, multiply. 10 times negative 1 is a negative 10. 10 times negative 2 is a negative 20y plus 20y equals negative 10. Okay, after you do the distributive property, this was the distributive property, you combine like terms. Okay, so I've got a negative 20y and a positive 20y. Well, that makes 0y, so I'm just going to cancel those out. I'm going to get a negative 10 equals a negative 10. Okay, so no variables. I lost my variables. So if I take a look, this mathematical statement is true. This is a true statement. That means my answer is infinitely many or many, infinitely many solutions. That means if I graphed it, they would have the same slope and the same y-intercept. This would be one line. Okay, let's practice another elimination. If you'll write that problem down, 5x plus 3y equals negative 9 and 2x minus 6y equals 18. Okay, we're going to eliminate the x's. If I want to eliminate the x's, I've got to multiply this one by a 2, because 2 times 5 is 10. And then I've got to multiply this one by a negative 5. That way, negative 5 times 2 gives me a negative 10. All right, so I'm going to come over here. 2 times 5 is 10x. 2 times 3y is 6y. And 2 times negative 9 is negative 18. Okay, I'm going to multiply this one. Negative 5 times 2x is negative 10x. Negative 5 times a negative 6 is a positive 30y. And then negative 5 times 18 is a negative 90. All right, so now I'm going to add these. Since these are opposites, I know they're crossing out, and I got rid of my x's. So I've got 36y equals negative 18, and negative 90 is a negative 108. Divide by 36, and my y is equal to a negative 3. Okay, so I'm halfway done. I'm going to put my y over here in the negative 3 spot. Then I'm going to take this bottom equation because it looks a little simpler, even though it's got a negative 6 in it. I'm going to take this negative 3 and I'm going to replace the y. Okay, now I'm going to multiply. Negative 6 times negative 3 is a positive 18. All right, so then I'm going to subtract 18 from both sides. And I get 2x equals 0. Divide by 2. And my x is equal to 0. So the point of intersection, the solution to this system is 0, negative 3. There's another video if you'd like to watch another video on how to solve elimination from YouTube. I've included it in this agenda. All right, see you guys tomorrow.